When we think of hamsters, we usually imagine a pet in a plastic tube. But in a rugged, natural landscape, these animals are solitary, aggressive survivalists built to endure a brutal environment. To study them without interference, we built a multi-level miniature biome. Unlike a standard enclosure, this system uses heavily compacted soil layers designed to mimic the weight and density of a subterranean habitat. Observing them requires a specialized ethical setup. We used sound-dampening materials to block external noise and outfitted the entire biome with infrared sensors, allowing us to monitor them in total darkness without the animals ever knowing we're there. Because these are highly reactive, paranoid prey animals, true observation depends on engineering an invisible microcosm where their survival instincts can play out naturally. Our protagonist arrives at the surface layer of the biome, taking its first steps into the new environment. Time is the primary threat. This graph shows the plummeting surface temperatures in the hamster's native range, tracked against a strict 7-day countdown to the first deep freeze. Within 1 week, the hamster must map the terrain, excavate a fortified multi-chamber burrow, and hoard enough calories to stay alive underground for months. As the temperature drops, the need for flawless engineering becomes a matter of life or death. Falling behind schedule means being caught on the surface when the soil freezes solid. As the sun sets, the hamster begins its active routine. It leaves the safety of the nest and enters the pitch-black tunnel system. Underground, the animal maps its world through touch. Its whiskers vibrate rapidly, brushing against the tunnel walls to feed the brain a constant stream of three-dimensional spatial data. It supplements this with specialized hearing to detect the vibrations of approaching predators, while laying down precise scent markers to ensure it can find the quickest path back to the deep chamber. If you want to see more of how this cute tiny hamster survives the week, make sure to subscribe. These calculated, sensory-driven movements allow the hamster to navigate and dominate a world where eyesight is completely useless. The burrow is a sophisticated multi-level structure that functions as much more than a simple hole in the dirt. This schematic breaks down the architectural zones: shallow exits, transit tunnels, and deep sleeping vaults. Thermally, the dense soil insulates, keeping the bottom chamber stable. Tunnel shapes manage internal airflow, trapping body heat below while cold air sinks into transit shafts. This creates a thermodynamic buffer, where the mass of the surrounding soil is used to maintain a life-saving pocket of warmth. By utilizing the principles of fluid dynamics and architectural depth, the hamster builds its own climate-controlled environment to survive the winter. To stock its larder, the hamster makes high-speed surface runs, stuffing seeds and grains into massive cheek pouches that expand back towards its shoulders. It then carries this haul back down to the thermal vault, caching the calories it needs for the months of cold ahead. Zooming out from our biome reveals how these individual survival habits ripple through the local environment. The endless excavation of tunnels serves a vital role by aerating the earth. This process breaks up compacted soil, allowing oxygen and water to reach the roots of the plants above. Furthermore, the seeds the hamster forgets or abandons in its underground caches eventually sprout, acting as a dispersal system for future plant growth across the landscape. The hamster's daily drive to survive creates the very conditions that keep the surrounding soil fertile and the ecosystem thriving. However, these wild populations are now facing significant threats from industrial agriculture and changing weather patterns that disrupt their hibernation cycles. Human expansion often leads to habitat fragmentation, creating barriers that prevent hamsters from reaching the foraging grounds or mates they need to sustain a healthy population. Protecting them starts with ethical observation, learning about their world without disturbing the behaviors that keep them alive. To help protect the cute tiny hamster and its wild relatives, share this video and click the link in the description to support wildlife conservation efforts. Ensuring the survival of this underground engineer preserves the essential biological processes that support the world above.